Hello, Dr. Mills and my esteemed audience. My name is David Jurist. I'm pleased to have this opportunity to visit with you to review my Capstone project for MIS 581 at CSU Global. In this brief presentation, I will address the rubrics of the course to show how this project fulfills the course requirements. I will address the full spectrum of elements that support the USDA's public stakeholders with my vision that matches your own. My project reviews the main components of the USDA organization, research hypotheses, complex literature review, datasets, analytics, my findings, conclusions, and some recommendations for some very valuable work. You will notice that my scholarly references are all accounted for at the end of the PowerPoint slides and in the Capstone write-up. The theme of the write-up focused more on the overall research, data, and analytics. The theme of the PowerPoint slides focused more on the business and organizational perspective. And this presentation focuses more on the highlights of the work as a finite project. What I wanted to accomplish in the project is to open the process of research and full data analytics life cycle for a model and simulation of the global food chain. A very ambitious undertaking, I do understand, that will take much time and effort to accomplish. A data analytics project, yes, but a research project even more so, with much discovery, adoption of tools, alignment with strategy of the USDA and the users of its data, and a clearer understanding of what all this work will require. My research hypothesis is that it is feasible to begin modeling the global food chain. It is begun with a consolidated data set for all food crop production correlated to the price of energy required to produce the food. The hypothesis is that the volume of global production of food grain crops varies inversely with the average annual price of West Texas Intermediate crude oil, which represents the cost of energy applied in the agriculture industry. The null hypothesis states when n equals 32 and r is the correlation coefficient, r is equal to -1. The alternative hypothesis states r is not equal to -1. Another hypothesis is that the world population grows in response to and as a result of the increasing production of food, not vice versa. This hypothesis will require additional hypothesis testing after this project is completed with the food production and world population statistics I have already gathered. During the literature review for this project, I discovered that ample scholarly literature is available, but not necessarily addressing the holistic global perspective, since food production is predominantly a local activity and its statistics collected nationally. Two treatises that most influenced my thinking were the volume by Gary Kleppel called The Emergent Agriculture: Farming, Sustainability, and the Return of the Local Economy, and another, The Accounting of the National Association of Business Economists Survey, which discussed how institutions are combining government data, including USDA data, with their own big data, with data analytics for business value formation. Such data are used, I quote, for purposes that include production and investment decisions, marketing and inventory management, and long-range strategic planning, unquote. That's from the Hughes, Cromwick, and Coronado treatise. Gary Kleppel says, in summary, very enlightening. a new kind of farming is emerging in America to improve our prospects for revolutionary change in our food system for sustainability and nutrition, unquote. Let's address the data. Since the data is U.S. Department of Agriculture data, it predominantly describes United States agriculture. Data from other nations is not readily available, except for the export-import data presented by the USDA. The data sets selected were limited to the food grain crops only, not crops dedicated to livestock. And I did not include any livestock statistics at all. The food grain crops are rice, corn, wheat, barley, soy, and oats. I also included West Texas intermediate crude oil historical prices and the world population statistics from the World Bank. All the data was time series data. My slogan for all of this research and for the analytics is, data has shape and shape has meaning. We look at the shape, especially as represented in our analytics and then in our visualizations. And from that, we can begin to interpret its significance for decision-making, finance, economics. Although I calculated them, the descriptive analytics would not be entirely meaningful in this project with time series data, such as the traditional statistical analysis before in inferential statistics, such as the mean, the mode, median, standard deviation, and variance. I had 32 years of data for world food production and for energy prices in that duration. I believe that a regression would be much more significant for predictive analytics and estimates of food production in the future and forthcoming energy prices. As volatile as they are and as difficult as they are to predict, we still nevertheless at least exercise the tools available to us. I focused on the correlation coefficient. I felt that for my thesis, namely that the level of world food production varies inversely with the expenditures required for the energy that produces that food, I felt that the correlation coefficient would be more meaningful. And I assumed that there is an inverse relationship between the two. For examining, cleansing, formatting, converting the dimensions, and preparing the data, I used the text editor in Weka. I also used WordPad and Excel. This was a very tedious and time-consuming task because the data in its raw form is in varying formats and dimensions, and I had to homogenize all of those so that the data I worked with in the analytical tools was consistent. I used the R language command line interface with version 3.4.4, Weka, and Tableau. My findings are as follows. These are detailed in the project write-up. The test of the null hypothesis failed, as the calculation of the correlation coefficient resulted in R equal to minus 0.4729. Hence, the null hypothesis was disproven by the data, not demonstrating a close inverse proportion between energy prices, and world food production. My write-up disclosed all the detailed observations about the data and the analytics, but some highlights are as follows, besides the test disproving the null hypothesis. More precise data about energy resources consumed by the agriculture industry and for specific crops will reveal better and more clear, precise test results in the future. Much data is available in the United States and for United States industries, but little is available for other countries. Little has been analyzed and published by the USDA except with economic reports, although much data is available. Little data is available for other countries, except in the case of export and import data that the United States Department of Agriculture does publish. Since food production is specifically a geographical activity, territorial and national mappings of the data will make for more revealing visualizations in the future. Security and privacy are not a prima facie concern because the USDA deliberately publishes this data specifically for these purposes of research and data analytics. The United States is the largest food producer in the world. However, China and Asia are the largest producers of rice in the world, which is the most abundant individual or specific food grain commodity in the world. Most importantly, or most strikingly, blockchain technology with IBM is going to enable new applications of information technology for the decisions that are going to help feed the poor and enable the producers and growers who can feed the poor. So allow me to summarize my conclusions for the entire project. The most striking and important conclusion is that the project should continue. It should be expanded. I'd like to add more analytical functions and algorithms and test more hypotheses, especially as I do more literature research and conceive of more potential hypotheses to test and do gather the data required to test them. This project only scratched the surface. I do keep a strong sense of purpose and motivation for discovering causal relationships and interdependencies in the models and submodels. An interactive, predictive, and prescriptive model of global food is feasible, but it is going to require long-term construction of a fully integrated interactive model with its contributory submodels of energy, weather, natural resources, fertilizers, and pest controls. These are all very important components. Allow me to quote from the Hughes, Cromwick, and Coronado treatise on the value of government data. The value of government data is difficult to measure, but it is clearly a substantial strategic asset for the United States business sector. Unquote. Ultimately, the intention of analytics, any business analytics, is to arrive at insights from descriptive, predictive, and prescriptive analytics that extract that intrinsic value of United States government data for actionable business, financial, and agricultural operations decisions. Future work that I would like to accomplish. As I mentioned, develop a water model, weather model, natural resource model, environmental impact model, and a volume and expenditure consumption model for fertilizers and pesticides. I'd like to follow the flow from cradle to grave, all aspects of an entire growth season cycle from preparation of the land, the acquisition of seed, the planting, the cultivation, care, protection, harvesting, distribution, geography, economic and investment decisions that growers must make, and then the export and import interpretation of the flow among sovereign nations, where the needs are the greatest and where the supply is the greatest, or the lowest, conversely. I'd like to make it online, interactive, colorful, geographical, with predictive and prescriptive analytics on real-time data with current information. I'd like to experiment with artificial intelligence and machine learning for integrated, innovative applications and perspectives that individuals can use. I'd like to build a data warehouse in the cloud and create an authoritative body of information, data, and knowledge. I'd like to expeditiously use cloud resources such as Amazon Web Services, Hadoop, Spark, and develop innovative online user applications that are very user-friendly, that do and perform very sophisticated analyses and results with striking reports and visualizations that are easy to use. I think I can assist prospective clientele with sophisticated planning services and online self-service tools. So I intend to continue to find and gather big data from all sources and all types, not just the textual, volumetric, and pricing data on a macroeconomic level that I've found. I'd like to use social data and begin to explore how those can all be linked to arrive at interesting findings and draw interesting conclusions for business purposes. This includes compiled data, perhaps some surveys, text, video, audio, image, and then the Internet of Things. Farmers are using sensing devices in their equipment, and some of the large companies like ADM and Cargill are already applying these. I'd like to comprehensively assess predictive, descriptive, and prescriptive algorithms linked to specific USDA strategies and the strategies of the growers and producers and processors who use their data. I'd like to advance macroeconomic and financial models with source data for investments, especially land procurement, financial and credit decisions, because a lot of the industry is funded by the creditworthiness of the individuals who do the work, and for operational decisions as well. Not to mention risk management and all of the hazards and risks that growers and producers face, as well as their insurers, those who insure for liability and the crops themselves. So let me prepare to close. Allow me to say that this was a very rewarding and educational project for me, and I do hope that what I have shared is very enlightening and promising to you as well. I discovered that this is a research and business value formation endeavor, not just analysis, not just data analytics, business analytics, not just statistics and programming. I reviewed the research hypotheses, discussed the data, the analytics, the findings, the conclusions and recommendations for continuing the research and analytics. I reaffirmed the value of the full data analytics lifecycle. Remember that data has shape, and the shape has meaning. So until the next time, enjoy abundant results in all you do. Thank you very much for your support, direction, professional consideration, and attention, and goodbye for now.